This is Foundations of Math and Pre-Calculus 10, Chapter 5.3. We're going to be looking at factoring trinomials. And this is an important skill, and you will continue to use it even into university calculus. It's important to become proficient, that way you can learn advanced concepts more easily in the future. So, factoring in the form of x squared plus bx plus c, we must find factor pairs of c, and they have to add up to b. Let's do this with an example. This is in the correct form. We just have an x squared, and b is 9 and c is 14. If there was a number in front of here, we can't use this method. We look at factor pairs of 14, 14 and 1. Now, this is a positive, so the only way to get a positive is if we multiply a positive and a positive or a negative and a negative. Since we're looking for a positive answer, both of these must be positive. And adding these two numbers up, we get 15. Since this is not equal to 9, we continue to factor. And the best way to factor is to increase the smaller number and then figure out what it goes into for the bigger number. So 14 divided by 2 is 7. Again, these both must be positive. Add them together and we get 9. This matches b. So all we need to do is do x plus this and x plus this. And there we are, it's factored. And if you want to check, you can just FOIL this and see if you come up with x squared plus 9 plus 14. Let's look at the next example. We need factor pairs of 8. They're both going to be positive or negative because this is positive. Since b is negative, we're going to make negative factor pairs. Negative 8 minus 1. This is negative 9. So that's not it. So we continue. Negative 4, negative 2, that equals negative 6. That equals b, so we can stop. So it's x and then minus 4. And x and minus 2. And that completes the factoring. Now the slightly harder case, this is what I call a medium level problem. We have a negative 12. That means we must have a positive factor and a negative factor multiplied to get negative 12. Since b is positive, our factor pair must have a larger positive number. Okay? Otherwise, the answer is going to be negative. So 12 and negative 1, that's 11. 6 and negative 2, that is 4. And just a reminder, 6 times negative 2 gives us our negative 12. And we're increasing this side. Negative 3 does go into 12. And we have 4. And this equals 1. And that's equal to b. If there's nothing there, it's implied that b is 1. So again, we just copy it down. X plus 4 and x minus 3. So just to recap, we are taking these numbers and copying them over because they add up to b. This is what we'd use until you get used to factoring. Once you're able to factor in your head, you don't have to use this method anymore. But be sure you're able to factor properly in your head. If you're making mistakes, please go back to this method. Now, what do we do if this is not a 1? Then we use the product factor sum method. So ax squared plus bx plus c. So here, this is clearly not a 1. We need the product. P for product. This is a times c. And for this question, we have 5 times negative 18. And when I don't put a dot there, and it's just a bracket, this is implied that it's a multiply. So this is negative 90. So now we do the factors. This is negative. This means we need a positive factor and a negative factor. And the negative factor must be larger because we have a negative b. So we'll start off with negative 90. And that's multiplied by 1. And the sum here is negative 89. So let's increase this to 2. This is negative 45 plus 2. And that gives us negative 43. Next, we increase and we get 3. And this is negative 30. And we get negative 27. That's good. We can stop because that matches B. So for this method, we copy the first term, 5x squared. Now we add x's to these terms. So this is negative 30x. And I don't literally mean add. We're multiplying negative 30 by x and 3 by x. And since they're not really like terms, we're just adding it onto the end. So this is 3 times x and negative 18. And why are we doing this? Because negative 30x plus 3x gives us negative 27x. And here, it's just convenient to work without the x. So that's why I'm saying we're adding an x. We're just putting it back in. Okay, the next step is what we did from the previous chapter. We factor in pairs. So here, we can factor out a 5x. That leaves us with an x minus 6. Okay, so 30 divided by 5 is 6. And it's a negative. And we're pulling out the x, so there's no x's left. Again here, we're dividing by 5x. The 5 comes out, there's nothing left. So it's a 1. And x squared divided by x is just x. Here, we can't pull out any x's, so we can only pull out numbers, and that's a 3. And we're left with x minus 6. And as before, we see a common factor here, so we can combine the monomials in the front. 5x plus 3, x minus 6. And that completes that question. Okay, the product here, 4 times 15, that equals 60. The factors, this is positive, so we're just looking at positive terms. 60 and 1, and the sum is 61, increases to 2, we get 30, that's 32, increases to 3, and we get 20, and that's 23, and that's good. We stop, we copy the 4x squared, we add the 20x, we add the 3x, and the 15. And we factor in pairs. And remember, the order doesn't matter, because if we switch it around, we'll still get the same answer at the end. So here, we can pull out a 4x, and we're left with x plus 5. Here, we can factor out a 3, and we get x plus 5. So we have 4x plus 3, because these are the same, x plus 5, and we're done with that problem. Now, here's a slightly harder problem. And one thing we can do is we can just ignore y for now. And we'll just ignore those. So we have x squared plus 6x plus 8. And the factors are 8 and 1, and they're both positive. and we get the sum of 9. That's not 6. We did this before, but it's always good to practice again. 4 plus 2, that's 6. So we have x plus 4, and we have x plus 2. Notice that we start off with x squared, x, and then no x's. Here we end off with y squared. We have a y, and then no y's. So instead of putting it in the first term, we can put the y in the second term. And now we're going to check by foiling or distributing and see if we get this answer back. If this works, then that means putting the y in the second spot is the way we should do this problem. So first, that's x squared. Outer, that's x times 2y, so that's 2xy. Inner, that's 4y times x, that gives us 4xy. And last, 4y times 2y, that's 8y squared. Notice that it doesn't matter how we're multiplying it. I always order the polynomial alphabetically and then with powers. So this has more x's, so it comes before xy. And y squared comes after xy. And we combine like terms, and we get back what we started with. So this method is good for factoring this harder polynomial. We have other problems to work on. We can format a problem like this. Find all the values of n that makes x squared plus nx plus 12 factorable. Well, we need to list the factors. We have 12 and 1, 6 and 2, 4 and 3. Now, n can be anything. N can be positive, n can be negative. But this is positive, so that means we need positive, 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 positive. But we can also have this, where this is negative and this is negative. This is negative, this is negative, this is negative, this is negative. They'll give us positive 12 as well. So this equals 13, this equals 8, this equals 7, this equals negative 13, negative 8, and negative 7. So there are 6 answers for n. Here's another problem. Let's do this. X squared plus 4x plus n. So we need to find an n that makes it factorable. Now this is a little bit different. So we need the sum of the factors to be 4. So we could do 2 plus 2. That's 4. So 2 times 2 is 4. So we're doing the sum first and the product second. And we're doing the product just to check that. We can do 3 and 1. That's also 4. So 3 times 1 is 3. We can do 5 minus 1, and that has a difference of 4. So 5 times negative 1, that gives us negative 5. And we can do 6 times 2, negative 2. And that gives us an n of negative 12. Question is, are these the right answer? Are there more answers? And there are actually an infinite number of answers because we can always keep adding 1 and subtracting 1 from this side, and the sum will be 4. And last type of problem. The height of a football in meters is determined by this expression. what is the ball's height after 1.1 seconds? So this is t, and h is equal to negative 4.9 times 1.1 squared plus 6, 1.1 plus 2. Plug this into the calculator, and you should try this to make sure that your calculator works the same way. The answer is 2.671 meters. However, going back to our first and second chapter, we want to ask the question, what is a reasonable number of digits to use? In the question, we're only using 2 digits here, 2 digits here, 1 digit, 1 digit. So our answer should not be more than 2 digits. So we should round this off to 2.7 meters. And that completes this lesson.